This lesson is for Mrs. Cucci's College Now PreCalculus class. We left off on lesson 5.3 on page 1.14. So you want to go ahead and open up your calculator file to that page. We'll get started. Okay, so given that tangent theta equals -2/3 and theta is in the second quadrant, find the other function values. So when you're given something like this, when you're given a trig function set equal to a ratio, what we can do is we can actually build a right triangle from this information. Okay, so what we're going to do is I'm going to just pop over to my paper here, and we're going to build ourselves that right triangle given my information. So create my right triangle. I'm going to pick an angle. Oops. And I'm going to call that angle theta. And then knowing, since this is what I'm given, tangent theta equals -2/3, and I'm in the second quadrant, this is all information that I'm given, okay? And annoying myself that I wrote that crooked, so I'm going to redo it. Okay. So tangent theta equals -2/3, and we are in quadrant 2, okay? So from this angle, tangent is opposite over adjacent. So opposite over adjacent. That's your 2/3. Okay. So what we need to do in order to find the other function values is find that missing side. And we know since we're dealing with a right triangle, we can use Pythagorean theorem. 2 squared plus 3 squared equals c squared. Or 4 plus 9 equals c squared. 13 equals c squared. And to get rid of a squared, you take the square root. So c equals the square root of 13. Okay? So I'm going to put that in there. Now we want to make sure that we keep this quadrant in mind, because that's going to allow us to decide whether or not our trig functions are positive or negative. So we're going to go ahead and find those 6 that we were talking about earlier. So we're going to start with sine theta. Of course, we're always going back to this original angle. Cosine theta and tangent theta, which I already know is -2/3. Cosecant theta, secant theta, and cotangent theta. So from this angle, sine is opposite over hypotenuse. 2 over the square root of 13. Now, from here I got to check my quadrant. Remember, second quadrant, all students take calculus. Sine is positive. We don't want to leave this with a radical in the denominator, so we're going to rationalize it by multiplying by square root of 13 over square root of 13, which is going to give us 2 radical 13 over 13. Okay. Cosine, pardon me, adjacent over hypotenuse, or 3 over radical 13. Second quadrant, cosine is negative. We have to make sure we rationalize. We get -3 radical 13 over 3. Okay. Now my reciprocals are simply that. They're reciprocal of the function value. So I can go ahead and I can take the reciprocal of 2 over 13. And remember, I'm going from the original, because if I go from here, I'm going to have to re-rationalize it. I want to make more work for myself. So cosecant is going to be the square root of 13 over 2. Secant is going to be negative square root of 13 over 3. And tangent is going to be 3/2. Cotangent is going to be 3/2. Okay. So again, when you're given a trig function and it's set equal to a ratio, you can go ahead and set up a right triangle with those given sides and find your missing side to find the rest of the function values. All right, so find the sine, cosine, and tangent values for 90, 180, 270, and 360 degrees. All right. What I'm going to do is I'm going to just put a quick sketch of our unit circle on here for us to kind of take a peek at. Okay. we know that this is the point 1, 0, 0, 1, negative 1, 0, oops, and 0, negative 1, okay, on these axes, right? All right, so what we're looking for are the values for 90, 180, 270, and 360. And we want that for sine, cosine, and tangent. So what I thought we'd do is I thought we'd just make a chart, okay? All right, so we're going to do 0, pardon me, 90, 180, 270, and at last 360. Now, keep in mind that these values come directly from these points, okay? The points are cosine, sine, okay, which we know goes to x, y. This is how we're finding these values. So sine at 0 degrees is this value right here. It's the y value of the point. So sine at 0 is 0. So then we can go to cosine, which is going to be your y value, which is 1. Tangent, we have to kind of keep this in mind as well. Tangent, we know, is the ratio sine over cosine. Okay? So sine over cosine, 0 over 1, we know 0 divided by 1 is 0. All right, so let's go to 90. Sine at 90 is going to be 1. Cosine at 90 is 0. And tangent at 90, 1 over 0, 1 divided by 0, is undefined. Okay? We actually get a vertical asymptote here. Okay? Okay, 180 degrees. Sine is 0. Notice the pattern, 0, 1, 0. Cosine, negative 1. And then again, 0. 270, negative 1. Cosine, 0. Tangent, undefined. So 0, 1, 0, negative 1, 0. Now, 0 and 360 are going to be the same because they're the same point. Okay? All right, so those are our values. And these you should really know off the top of your head. Okay, so we're going to find sine of negative 90 and cosecant of 540. Okay, so let's start with sine at 90. What we can do is we can kind of draw, well, we can draw a rotation diagram for negative 90 so we see where it is. Okay, remember, we like to start in initial position or standard position with my initial ray along the x-axis and the vertex at the origin. Negative rotations are going to go clockwise, so negative 90 is going to be right here. Okay, and we know that negative 90 is going to be the same thing as 270. These two things are coterminal with one another, if you remember, if we go back, okay? Coterminal, meaning if I went from here to here, that's 270 degrees, that's coterminal angle. Shares the same initial, same terminal. So sine at 270 degrees, here's my point, 0, negative 1. Sine is negative 1. Okay, so 540, that's pretty big. All right, so what I'd like to do is I'd like to get this number so that it's less than 360. So what I'm going to do is I'm going to find its coterminal angle, because we know an angle and its coterminal angle are going to have the same function value. All right, so what you can do is you can simply take 540 and subtract out a factor of 360 degrees. When you do that, we wind up with 180. So what we're going to see is that cosecant of 180 is going to be the same as cosecant of 540. All right, so again, here's 180 degrees, right? So here's my initial, here's my terminal. It's going to go from here to here. This is point -1, 0. Cosecant is 1 over sine. Sine at 180 degrees is 0. So 1 divided by 0, we know, is undefined. That means cosecant of 540 is undefined. All right, so we have some reference angles that you guys need to be aware of. We've got 45, 45, 90 triangle. We have our 30, 60, 90 triangle. These two triangles have to be memorized, guys. We can get every point on our unit circle from these two reference angles. So these are going to be very important for you to know. So with 45, 45, 90 triangle, we have 1, 1, square root of 2 as our hypotenuse. And for our 30, 60, 90 triangle, we've got 1, 2, square root of 3 as our hypotenuse. So again, please take the time to memorize these. You will be quizzed on them. All right, so reference angles, very important. The reference angle for an angle is an acute angle formed by the terminal ray of the angle and the x-axis. Reference angles are always acute, meaning smaller than 90 degrees or less than 90 degrees, okay? Reference angles are going to become very important when we start to solve trigonometric equations, so it's very important that you know how to do these and do them well. All right, so let's move over here. All right, so I want to find the reference angle for 225 degrees and for negative 780. All right, so how I'm going to start is by drawing a rotation diagram. All right. So I know we're in standard position to start. 220 degrees is going to be greater than 180 and less than 270. So let's say about here. I want to show my direction of rotation. The reference angle is the angle created with the x-axis and the terminal ray. So here's my terminal ray, here's my x-axis, it's this angle right here. Okay. To find this angle, what I need to think about is, right now I have this whole rotation. I only want this piece. So how can I get this piece from the whole 225? Well, if I were to take out this portion right here, which we know to be 180 degrees, that would leave us with the leftover. So we're going to do 225 minus 180. That's going to give us a reference angle of 45 degrees. Okay. So, just kind of a side note, we know that sine of 45 is the square root of 2 over 2. We know cosine of 45 is square root of 2 over 2. Tangent of 45, which we know to be sine over cosine, anything over itself is 1. Okay. Next one we're going to find is negative 780. Now, I don't like that number. It's really big. So what I want to do is I want to find a coterminal angle with negative 780 that's going to be less than 360. So what I can do to get that is simply add factors of 360 until I get a value that suits my needs. So negative 780 plus 360 is going to give me a value of negative 420, which is still too big. So I'm going to take that and I'm going to add another factor of 360, which is going to give me 60. All right, so there is the angle that I'm dealing with. So now 60, here's my initial, here's my terminal, here's my angle of rotation. You notice 60 is going to be my reference angle, okay? 60 is in the first quadrant. It's an acute angle. So 60 is my reference angle. Okay, so we want to find sine, cosine, and tangent for this one as well. Now for this one we found using the reference angle. Now here's the issue. I'm gonna kind of backtrack on you. I apologize. We used 45 as a reference angle. The actual angle is 225. You need to go back and check here. So sine at 225. It's going to have the same function value, but we have to check our sine. All students take calculus. Since we're in the third quadrant, it's got to be negative. Okay? Same thing with cosine. Negative. Tangent, however, because it's in the third quadrant, tangent's positive, it's still going to be a positive 1. All right, so now let's find sine of negative 780, cosine of negative 780, and tangent of negative 780. All right, since what I did was take out factors of 360, I know that the terminal, right, and I took out 2 rotations, would have looked like this to begin with. Okay, so it's still finishing in that first quadrant where we know everything is positive. Okay, so what I'm doing is I'm essentially looking at it as sine of 60 degrees. It's the reference angle. Sine at 60 is square root of 3 over 2. I know it's going to be positive because it's in my first quadrant. Cosine at 60, or cosine at negative 780, and we can write it like that if we'd like, is going to be 1/2, positive first quadrant. Tangent, we have to do sine divided by cosine. And I apologize, I know I'm going off the page here and I'm out of room. Let's make this so we can see it. Okay, so sine over cosine, so square root of 3 over 2 over 1/2. Complex fractions, we know we multiply by the reciprocal, and we get the square root of 3. Again, first quadrant, everything's positive, so it's going to be positive square root of 3. All right, using a calculator, you're going to find the function values for each, rounding each to 4 decimal places. Okay? You all know how to do this. I'm not going to spend time going over this. This is nothing new for you. So just make sure you have these filled in for class tomorrow. And then we will take a look at them. Okay, so for these, what we're doing is we're finding the value of theta. Now remember, theta represents the angle. So we know in order to find the angle, we have to use the inverse. Okay? Oops. So we're going to be doing sine inverse, and I'm not sure I'm in the right setting. I'm in radians, I need to be in degrees. So I'm going to click up there, do document settings and degrees. Okay, and let's see if this will give it to me. So this is what I want to be plugging in, okay, because this is going to equal theta. So by taking the inverse, I'm finding the angle. Okay, so I'm just going to use a scratch pad, and my angle is in degrees, so I'm okay. I'm going to type that in and hit enter. So now what I got was 16.3 approximately. But because we want to be in the second quadrant, what I need to do is find that angle in the second quadrant. Okay? So if it was 16.3, we want it in the second quadrant. What we're going to do is we're going to use the rule 180 minus theta. Okay? So 180 minus 16.3 is going to give me an angle of 163.67. Okay. Alright, so if you're given the reference angle, if you need the other angles, there are your rules. Theta, 180 minus theta, 180 plus theta, and 360 minus. That's per quadrant. And I know I'm over on my time. I apologize, guys. All right, so this last one, cotangent, you're going to essentially do the same thing. You're going to do cotangent inverse. Okay? And I'm going to let you use this since you guys are in pre-calc now. I'm not going to have you actually flip this for me. And what I think we'll do is we'll pick up with this in the next video. I'm going to make this a third video because I have a little more to cover. So please come in prepared with any questions, and we'll go from there. Thanks, guys.